Hello everyone. Okay, so in this video we're looking at the graphs of modulus. So in the last video we just looked at the modulus and modulus equation. Now this video we are looking at the graphs of a modulus and what it looks like. So what do modulus graphs look like? So they're gonna take some sort of V shape, right? And every modulus is going to be a V shape like this. We're not going to have like an end, like a upside down V shape or anything. It's always going to be a positive V shape. So here's a graph of the modulus here. So why do we get that V shape? So let's have a look here. So I have my X values here, I have my function, and then I have my Y values. I'm going to plot some coordinates. So this is just going to be the plain old regular degular modulus of X. So the modulus of minus 3 is going to be positive 3. The modulus of minus 2 is going to be 2. When x is equal to minus 1, the modulus of minus 1 is equal to 1. Modulus of 0 is equal to 0. The modulus of positive 1 is equal to 1. The modulus of 2 is equal to 2. The modulus of 3 is equal to 3. So as you see here, I have no negative values. So if I plot these out, 3 minus 3, minus 2, 2, minus 1, 1, 0, 1, 1, 2, 2, 3, 3. So we never go below the x-axis. We never go below the x-axis. That is why I have a V shape. Because in normal graphs, if I was just plotting the function x, for example, I was just plotting the x, right, it would continue on down here, but it doesn't, right? Because it is now forcing all of my negative input values or my negative x values to be positive. So that's why we kind of get a V shape. So how do we plot a modulus, or how do we sketch or graph a modulus? So the best and easiest way to do it is you're going to need to find a few points of your modulus. So we can use graph of modulus functions to solve a modular equation. To sketch a graph of modulus functions, we can find at least 4 points. So we can always find 4 points within my modulus. We can find x when f of x equals 0. So the root of the function. So when f of x equals 0, or when my modulus graph equals 0, that is going to be this part right here. So like the apex, the pointy bit of my modulus function. It's to where it touches the x-axis. So we find where my modulus is equal to 0. We then find one value of x. We evaluate one value of x to the right. We evaluate one value of x to the left. Or finally, we could find where it crosses the y-axis by letting x equal 0. So you could do an input-output value table like this, but you're never going to be specified your domain or your input values for your function. So it's kind of best to find where the apex is, or like this pointy bit is here. Find one point to the right, one point to the left, connect them up, bada boom, bada bing, right? So let's look at an example here. Sketch a graph of the function 3x plus 5, and hence solve the equation. The absolute value of 3x plus 5 is equal to 2. So I first need to find my first point, which is 3x plus 5 equals 0. So 3x is going to equal minus 5. X is going to equal minus 5 over 3. Gorge. So my first point is minus 5 over 3, 0. Now I need to find a point to the left and right. So let me plot this out here. So 2, I'm going to go up in 2, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Actually, no, I'll go up in 1. So go up in 1. So go up in 1s. 1, 2, 3, 4, 5, 6. So that's going to be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then my x values here: minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. 2, minus 3, minus 4. So minus 5, 3. So that is equal to minus 1.66666. So that is going to be around here on my graph. So minus 1.6660, or that's going to be around here. on my graph. Now I just need to find a point to the right and I need to find a point to the left. So any point will do. So I'm going to take x is equal to -1, for example. So that's 1 point to the right here. So I'm just going to say x equals -1, sub it in. The absolute value 3 times -1 plus 5 equals -3 plus 5, which is equal to absolute value of 2, which is equal to 2. So that point is here. I got 1 point there. Gorge. My next point I'm going to take is -3, because why not? So I'm going to take x is equal to -3 as my final point. X is equal to -3. Absolute value 3 times -3 plus 5. That's going to be the absolute value of -9 plus 5. The absolute value of -4, which is equal to 4. So my coordinate here is -3, 4. And I have this point here, -3, 4 is up here. And that's it. That's all I need. Now you take out your ruler and connect them up. So you always connect them to the green one. So this here, connected, and then this one here, connect that up. Boom! Bada boom, bada bing. There's a graph of my modulus. Now it's asking me here, right? Hence solve the equation when 3x plus 5 equals 2. So we want to find now where my modulus is equal to 2. So we go now to my y is equal to 2. Draw a line. Label the 2 points. That's here and like here. Go down and read them. So I'm going to have here, when reading my points, again, don't have to be terribly accurate with your graph. I'm going to x is equal to -1. And I'm roughly going to have x is roughly equal to -2.25. That seems about fair enough, doesn't it? Going down here, ding, 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 ding. Yeah? So, again, I'm reading from a graph, so I am allowed some margin of error in that case. But that's it. That is how we solve that. So, right, so let's look at some practice problems. So, the first question here, solve the equation, the absolute value of x minus 3 is equal to 5 by graphing and using algebraic methods. So, I want to graph the modulus of x minus 3. So the first point I need to let my modulus equal 0. So x equals 3. So my first coordinate is 3, 0. That's down here. My next point, I need 1 to the right. So I'm just going to choose x is equal to 4. So the modulus of 4 minus 3 is equal to the modulus of 1, which is equal to 1. So my second point is 4, 1. Boom. And then finally, my last point, I need 1 point to the left, so x is equal to 2. The modulus of 2 minus 3 is equal to 5. Oh, no, equal to 5. It's equal to -1, which is equal to the modulus of -1, which is 1. So 2, 1 is my third point here. Now I just connect them up, like so. Connect them up like so, like this. Right, now it's asked me, so solve the equation x minus 3 equals 5. So I have to go to where my function is equal to 5, go across, and I see it intersects here. And if I bring that down, so that's going to be x is equal to 8. And if I bring this down here, x is going to equal -2. So graphically, x equals -2 and x equals 8. Now, can I check? I'm going to check my answer now with using algebra. Right, so I have the modulus of x minus 3 is equal to 5. I only have one modulus here, so that is just going to be x minus 3 is equal to plus or minus 5. So x minus 3 equals minus 5. X minus 3 equals positive 5. X is going to equal minus 3 plus minus 5 plus 3 is equal to minus 2. And then 5 plus 3 is going to be x is equal to 8. So there you go. I verified my solutions there. Let's look at the next one. Solve the equation 2x minus 2 equals, the modulus of 2x minus 2 is equal to 6 by graphing and using algebraic methods. So again, I need my points. So my first point is we're going to let 2x minus 2 equal 0. X in this 2x is going to equal positive 2, x is going to equal 1. So 1, 0 is my first point. Second point here. So let me plot this point down. 1, 0. So I need a point to the left and right. So a point to the left, I'm going to choose x as 0, because why not? So 2, the modulus of 2 times 0 minus 2 is equal to the modulus of minus 2, or the absolute value of minus 2, which is 2. Which is 2. So a point here is 0, 2. 0, 2 up here. And then finally, x is equal to... You need one more point to the right, so I'm going to say x is equal to 2, because why not? So 2 times 2 minus 2. That's going to be the modulus of 4 minus 2, which is the modulus of 2, which is just equal to 2. So that's my other point there, 2, 2 here. Gorge. Connect them up and plot them out. Connect them up and plot them out. Right, so now this one's asked me here, solve for where the function's equal to 6. So I'm going to go to 6 on my y-axis and go across. So if I'm right, that it intersects here, so I'll be ding, 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 go down. I get x is equal to minus 2, and x is equal to, oh, I'm a bit off here on this line, right? So x is not going to be equal to minus 2, is it? Nope. There you go, that's more better. I sketched it a bit bad, my apologies. Here, the intersects here, ding, 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 go down, x is 4. So my two values here is going to be x is equal to minus 2 and x is equal to 4. Now I can use algebra to verify my answers. So modulus of 2x minus 2 is equal to 6. So 2x minus 2 has to equal plus or minus 6. So 2x minus 2 is equal to 6. 2x minus 2 is equal to minus 6. 2x is equal to 8. X is equal to 4. Oh, there you go. And 2x is equal to minus 6 plus 2 is minus 4. X is equal to minus 2. So there you go. I verified my answer there using algebra. Right. One more here. Solve the equation for the modulus of 4z plus 5 is equal to 3 by graphing and using algebraic methods. So first point I need to let 4z plus 5 equal 0. So that is going to be 4z equals minus 5. Z is going to be minus 5 over 4, or minus 1 1/4. So that's going to be here. So minus 5 over 4, 0. Right? Next point here. Point to the left and point to the right. I'm just going to choose x is 0 because that's a nice point to use. So 4 times 0 plus 5 is equal to the modulus of 5, which is equal to 5. So go to 0, go to 5. There's my second point. And then I need a point to the left. And I'm going to choose... I'm going to choose minus 2. X equals minus 2. 4 times minus 2 plus 5 is going to be equal to the modulus of minus 8 plus 5, which is the modulus of minus 3, which is 3. Oops, spoiler alert. I accidentally discovered one of my answers, but We'll leave it. Right, so connect these up. Bing. Bong. Right, x minus 2 is minus 3, yeah. Right, so now it's asking me here to solve for when my modulus is equal to 3. So draw across here. Well, we found out here it works when x is equal to minus 2. And then I'm getting here when x equals to like minus a half. I think that works, minus a half. So I have x is equal to minus a half and x is equal to minus 2. So let's check my answers using algebra. So 4z plus 5 is equal to, modulus 4z plus 5 is equal to 3. 4z plus 5 equals 3. 4z plus 5 equals minus 3. So I have 4z is equal to minus 2. Z is equal to minus 1 half. Here I have 4z equals minus 8. Z is equal to minus 2. And there you go. And they are, oh, did I say x? I meant z. But you get the point anyway. Z. So there you go. That was me from the graph, and that was me doing it algebraically. Finally, let's look at one exam question I can manage to find here. So this is from the 2012 sample paper. Not even the actual paper, a sample paper. So the graph of the function f of x, or x minus the modulus of x minus 3, and g x equals 2 are shown on the diagram. Find the coordinates of a, b, c, and d. So I need to find a, b, c, d. So I know a few things. I know this point here. At this point here, y is equal to 0, or my inside of my modulus is equal to 0. I know at this point here, x equals 0. And I know at these points here, my modulus is going to be equal to 2. So let's solve d first. So d happens at x equal to 0. So the modulus of x minus 3, 0 minus 3, modulus of minus 3, which is positive 3. So this point here is going to be 0, 3. Gorge. Let's do c next. So c happens at y is equal to 0, or my modulus is equal to 0. So x minus 3 is equal to 0. So x minus 3 equals 0. X is equal to positive 3. So my point here is 3, 0. Gorge. And then let's look at a and b. So I want to look where the modulus is equal to 2. So x minus 3 is equal to 2. So x minus 3 is going to be equal to plus or minus 2. So x minus 3 equals minus 2. X minus 3 equals positive 2. X is going to equal to 1. And x is going to equal to 5. So obviously this point here is going to be 1, 2, because it's the leftmost one. So 1, 5, and then b here is going to be, oh sorry, not 1, 5, 1, 2. And here is going to be 5, 2, because b is the leftmost one. So d is 0, 3, c is 3, 0, a is 1, 2, and b is equal to 5, 2. And there you go. And that's our exam question done there. Right, so that's modulus graphs. So in the next video, we're going to be looking at modular inequalities. And I hope this video was some help, and I'll catch you guys later. Bye.